Hello, Math 45. This is Cindy Enrique, your instructor. We're going to continue lecture with Chapter 5, and we are on page 1. So for section 5.1, we're going to be talking about the quadratic function. So let's think about some of the characteristics of a parabola. So down below, we have a happy parabola. You might be thinking, a happy parabola? What are you talking about? Well, if I draw a parabola that looks like this, you can kind of think of it as it smiling at you, okay? So if you think of a happy parabola, then you know that it's going to be positive, okay? You can also have a sad parabola, and you can think of that as frowning at you. So that's my sad parabola. And this is a negative parabola. I can also say that this parabola, it opens down when it's sad, versus this one, it opens upward, okay? So a happy positive parabola opens up. A sad negative parabola opens down. So those are some things that you can kind of think about when you're thinking about a parabola. Now, in particular, we're thinking about this parabola and this graph. So we have our x-intercepts. Remember that the intercepts of x are along the x-axis. So we have -1, 0 and 3, 0. We also have our y-intercept, which is along the y-axis, and that's here. That's 0, -3. And we also have something called the vertex. The vertex in any parabola, so vertex, is always going to be either the minimum or the maximum point of parabola. So if I have a happy positive parabola, then I have a minimum point. If I have a sad negative parabola, then I have a maximum point. So in this case, because it's a happy smiling parabola, then I'm going to have my minimum point. And that minimum point happens to be 1, -4. The axis of symmetry is going to be x is equal to 1 because the x coordinate of the parabola is 1. So that's how we get the axis of symmetry. You cannot get axis of symmetry until you know the vertex. You absolutely need the vertex before you can have your axis of symmetry. Okay, so that's kind of our general introduction to our parabolas. Now let's look at some examples. So it says, find the x and y intercepts, the vertex, and the axis of symmetry from the following graphs. So we're not doing any computation, we're just looking at it visually. So okay, so let's really look at this visually. So if I'm thinking about my x-intercept, that's here and here. So this point represents one of my x-intercepts, and that would be a -5 and a 0. This other x-intercept is 3 and 0. So x-intercepts, I have 2, -5, 0, and 3, 0. The next thing I'm going to be looking at is the y-intercept. The y-intercept is here. It's along the y-axis. So that's 0, 7. So y-intercept is at 0, 7. Now, the other thing I'm going to be looking at is my vertex. So it looks like that is going to be my vertex. And if I kind of inspect that a little bit further, I can see that that vertex is at -1 for my x value, and that y value is halfway between 7 and 8. That's why I zoomed in on it so much. So you can see it's not exactly at 7, it's not exactly at 8, so it's about a 7.5. So when I zoom out, I'm going to rewrite this. So my vertex is at -1, 7, 0.5. So I have my x-intercept, I have my y-intercept, I have my vertex. The only thing I'm missing here now is going to be my axis of symmetry. So my axis of symmetry is always x equals, and whatever that value of x is for my vertex. So it happens to be -1. Okay, so that was our first graph. Now let's look at that second graph. Well, if I'm thinking about the x-axis, I'm here. Here's my x-axis. Is there any way that that red parabola is going to hit that x-axis? Absolutely not. So in this case, for our x-intercepts, we say none. There's no way that that red graph is going to be along that x-axis there, which is fine. Now we try to see if there's a y-intercept. Well, it looks like we do. So there is my y-intercept. So I can say that my y-intercept is going to be 0, 7. So the next thing that I'm going to need is my vertex. The vertex here, I have a minimum point, and that is going to be here. So it looks like that point is 2, 3 for my vertex. So then my axis of symmetry is going to be x is equal to whatever this value is, which happens to be 2. Okay. Now we're going to go into the general form, we're going to go into the standard form of the quadratic function. So the standard form, or better yet, I like to call it the vertex form. I like to call it the vertex form because the vertex is actually given to you. And the vertex is actually a very special ordered pair, and that's h and k. So here's my h, and here's my k. So there's my h and my k. So we also know that the axis of symmetry is given by the equation x is equal to h. I also know that if a is positive, it opens upward. If a is negative, then it opens downward. So look at the example below. It says for the following functions, determine which way the parabola opens. Find the vertex and find the axis of symmetry. So, well, I know the way that it opens really depends on my a value. So a here is 2. It's positive, so I know I'm looking at a happy parabola. That tells me that it opens up. Okay. The next thing I'm going to be thinking about is my vertex. If I'm thinking about my vertex, I know it's a special ordered pair where I have h and I have k. My h value comes from here. That is going to be my h value. My k value comes here. So that's going to be my k value, just like I have it in that formula. So I definitely know that k is -5. I have no doubt about it at all. K is equal to a -5. Now the h value, I have to be careful. Notice how this h is a, oops, sorry about that. Notice how this h is a -h, but in here it's a positive h. So that actually tells us a lot here. It tells us that the h is actually going to be the opposite in the vertex. So it's a +6 in the formula. So the vertex is actually going to be a -6. Okay? So then, of course, that tells us that the axis of symmetry is going to be x is equal to -6 because that's what the h value is. Okay? The axis of symmetry is always x equals to that h value. Okay? And if you're like, wow, I didn't understand that. That's okay, we have a couple of more. So here, let's look at this a value. This a value is a -3. It's negative. So when it's negative, it's going to be sad parabola. So we know that this is going to open down. I can also tell you the vertex, which is here and here. So I have my h and my k value. So the vertex for my h value, it's not a -2, but it's actually going to be a +2 for my h. and that k value is -4. And of course, I can tell you now my axis of symmetry. That's x is equal to 2. All right. Now, looking at part C. Well, here, what's that a value when it's not there? Whenever there isn't a value, we can always assume it to be 1. So a is equal to a +1. That means it's positive, so it's smiling at me. So that tells me that it's going to be opening upward, okay? I can also tell you the vertex, that's my h, and my k value. So my vertex is going to be a -7 and a +3 because that was my h and my k value. Now that I have my h value, then I know that the axis of symmetry is going to be x is equal to that h value, and that h value is a -7. Okay? I hope that helps. Now, the other way that we're going to have is the general form. So if I have something called the general form, that's that ax² plus bx plus c. Okay? And to get the x coordinate of the vertex, I'm going to get this h. So x coordinate of the vertex, and I use that formula of -b over 2a. The y coordinate of the vertex you get by plugging in the x value into your original equation. You're like, huh? Don't worry, we're going to practice with that. So, for example, it says, for the following functions, determine which way the parabola opens, find the vertex, and find the axis of symmetry. So, okay, I'm looking at this, and I have some information. I can tell you what my a, my b, and my c value are going to be. So, my a value is 1, since there isn't one, so we assume it to be 1. So, a is equal to 1. My b is equal to a -10, and my c is equal to a +24. So at least from that a value, I can tell you that it's going to open upwards because it's positive. So opens up. So there's one way, or one answer that I have. Which way does it open? It opens up. Okay. Now, the second thing that it wants the vertex. So to find the x coordinate of the vertex, I use -b over 2a. So negative, plug in my b value, and 2 on the bottom, and plug in my a value. So here, that b value is a -10, and my a value is a +1. So I actually have a +10 divided by 2, which is 5. So now I know that this vertex, I have a +5, and I need to find what that k value is. So to find that k value, I plug in that 5. So this is what I mean by x is equal to 5, plug into equation to find k. So for my original equation, I have y is equal to x² minus 10x plus 24. So x² minus 10x plus 24. So that value that I'm plugging in is 5. And when I plug that in, that 5 in, I'm going to get my k value, or my y value, is equal to a -1. So when I do that, I get -1. So now I have found my vertex. My vertex is that h is equal to 5, and my k is equal to -1. Now the next piece of information that they want is the axis of symmetry. So the axis of symmetry is just x is equal to 5, because that is my h value. Okay, we're going to do the exact same thing for part B. So here I have my a value is -1, my b value is -10, and my C value is negative 20. So, because the A value is negative 1, that tells me that it's going to open down. Okay, because it was negative. Perfect. Now we are going to find the x coordinate of the vertex. So x coordinate of the vertex. So I still have that same formula, negative b over 2a. So what I'm plugging in here is my b value, that's a negative 10, and my a value, which is negative 1. So I'm going to have a positive 10 divided by negative 2, which is a negative 5. So now I know that my vertex, at least half of it, is negative 5. That's my h value. Remember, to find my k value, I plug it in. So my original equation, I have a negative x squared minus 10x minus 20. And that value that I'm plugging in is a negative 5. Well, when I plug that all in, I'm going to get my answer, and that answer is a positive 5. So now I have my vertex. So now I can tell you that my axis of symmetry is going to be x is equal to a negative 5. Okay. I hope that helps you. We have more problems because it's a very long chapter or very long section, and that's okay. So it says, determine the equation of the parabola whose graph is given below. Note we could not clearly identify the intercepts. What do you mean we can't identify the intercepts? Well, I know the y-intercept, but I clearly don't know the x-intercepts. Remember, the x-intercepts run along the x-axis. So here, that graph along the x-axis, it looks like a decimal or a fraction. So that really doesn't help us much. So we don't really like it. And you're just like, okay, well, what information can I actually grab from this graph? Well, I can definitely tell you the y-intercept. Okay, there we go. So y-intercept, that is 0, negative 1. I can also tell you the vertex here. So the vertex is negative 2, negative 3. Okay. So now that I've kind of zoomed that in and zoomed it out, now I have the most important information. So now let's think about what they're actually asking us to do. They want us to determine the equation of a parabola. Equation of a parabola. So whenever I think of this word parabola, what I'm thinking about is this is always going to be degree 2. And a parabola is that thing that has that vertex, depending on whether it's a happy parabola or a sad parabola. So your goal is to write it as an equation with degree 2. That's the exponent in case you have forgotten. The goal is to write it as an equation with degree 2. So there are two ways of writing it. The first way is that we have f of x, that's our function notation, as a x minus h squared plus k. And we're going to go ahead and call that the vertex form. Okay. The second way that we can write this is going to be ax squared plus bx plus c. And that we're going to call as expanded form. So we have our two different ways of writing the equation. So because we don't have the x-intercepts, so don't have x-intercepts, so that kind of tells us how we're going to be approaching this problem. the way we're going to approach this problem is by identifying what we do have. So what we do know, so things that we know, is that we know the vertex to be -2, -3. We also know that the y-intercept is going to be 0, -1. Remember, this is our h and our k in the vertex. We refer to it as h and k. And the y-intercept, we like to refer to that as my x and my y. So we're going to rewrite this as our general form. So we have, let me rewrite that. Here we go. Okay, now you can see that I was trying to write the first equation. So we have that f of x is equal to a x minus h squared plus k. And of course, hopefully by now, you know that f of x is just really a y, okay? Now I'm going to have my a. So what I'm going to do here is I'm actually going to be plugging in my vertex. So plug in values from vertex. So that's my h and my k. So I have my x here. So I have to be careful. If my vertex of h is -2, then I'm going to rewrite this as the opposite, which is a +2. And that k value is a -3. Okay. So now I have that. Now the other piece of information that I have is the y-intercept. So let me just rewrite this. So y is equal to a x plus 2 squared minus my 3. So the next thing I want to do at this step is plug in values from my y-intercept. And remember that y-intercept was 0, -1 for your x and your y. So that y value, I'm going to plug in a -1. So that x value that I'm plugging in there is going to be 0. So from here, what I'm going to do is I'm going to get the a by itself. So solve for a. So, okay, -1 is equal to a. 2 plus 0 is just 2. 2 squared is just going to be 4. So I'm going to rewrite this as -1 is equal to 4a minus 3. From here, to get the a by itself, I'm going to add 3 to both sides. So I can get 3 minus 1, which is 2, is equal to my 4a. From there, divide by 4, divide by 4. So I'm going to get that 1/2 is equal to my a. Now that I have my a value, I can rewrite this, okay? So now I have that a is equal to a 1/2. I also have my vertex, which is -2, -3, as my h and my k. That's all I really need in order to rewrite this in my vertex form. So I know that f of x is equal to a x minus h squared plus k. And I have all my pieces of information. So f of x is equal to 1/2 x plus 2 squared minus my 3. So there is my equation in vertex form. Okay. If, and only if, they had asked you to write it in expanded form, then that means to actually solve or multiply and FOIL out what we have. Well, expanded form. We take what we have. So we have that f of x is equal to a 1/2 x plus 2 squared minus 3. So what that tells us is to actually write out the x plus 2 twice. So So then from here, because I have, excuse me, because I have x plus 2 and x plus 2, I'm going to go ahead and FOIL that out. So when I FOIL that out, I'm going to have x squared plus 2x plus 2x plus 4. But if I combine those two x's together, then I'll have an x squared plus 4x plus 4. So I still have the 1/2 out in front and the minus the 3 for my f of x. So now I'm going to distribute that 1/2 into everything. So 1/2 x squared plus, now that 1/2 times that 4x, or half of 4 is 2x. And again, I'm just distributing that 1/2. So distribute 1/2 inside my parentheses. So again, I did this one, I did this one. So now this 1/2 times 4, or half of 4 is 2, and I have minus 3. So f of x is equal to 1/2 x squared plus 2x and 2 minus 3, that gives me a negative 1. So now I have this in my expanded form. So it really just kind of depends on what the question and what it's asking you. So if it's specifically asking you to write it in vertex form, then you could have stopped up above. But if it's asking you to write it in expanded form, then you need to write a little bit more, do a little bit more math, and get it into your expanded form. You just have to make sure to read the directions carefully, okay? All right. So now, let's go on to our next page. So for this one, if I zoom in, well, let's read it first. It says, determine the equation of a parabola whose graph is given below. So again, that whole equation of a parabola, that word parabola, you know you're looking at an equation that has degree 2. And here we actually have the x-intercepts. So that's fantastic that we have these x-intercepts. They're given to you beautifully. So we have the x-intercept here, and we have the x-intercept here. So I'm going to write it. X-intercepts. We have 1, 0, and we have 4, 0. And why not give you the y-intercept? The y-intercept is there as well. So the y-intercept is going to be 0, negative 8. So because I have my x-intercepts, I can actually write this in a very generic form. So since we have x-intercepts, then can get equation by another method. So here it's going, this is what we're going to have. So we're going to have our general equation as f of x is equal to, and remember you always have a. Now I'm going to have x minus, this is going to be parentheses, and x minus my parentheses. And you might be thinking, oh gosh, what does she mean about these parentheses? Well, in those parentheses, you're going to plug in the x-intercepts. We already know those values, so why not use the values that we have? So, okay, let's do this. Well, I have f of x is equal to a, and that first x-intercept that we have is here. It's, oops, let me go back. Here it is. It's 1, 0. So that x-intercept that I'm plugging in is going to be a 1 value. So I'm going to have minus 1. And for that second x-intercept, we have 4. So we're going to have x minus 4 for that second x-intercept. So then I'm like, okay, perfect. I plugged in the x-intercepts. That's what I did. So plug in x-intercepts. So now that I have, and remember, f of x is just y. So now I have y is equal to a, x minus 1, and x minus 4. Well, what's the other piece of information that we have? That's right. That's the y-intercept. So I'm going to plug in my y-intercept, which is 0, negative 8. That tells us that x is equal to 0 and y is equal to negative 8. So whenever I see a y, it'll be negative 8. Whenever I see an x, that's going to be 0. So I have my y value. I have a. That x value that I'm plugging in here is 0. So I'm going to have 0 minus 1. I see an x again, so that's 0 as well. Plug that in, and I have a minus 4. So now 0 minus 1 is negative 1. 0 minus 4 is negative 4. And I know that a negative times a negative is a positive. So 1 times 4 is positive 4. So I really have this 4a down here. And now to get the a by itself, I'm going to divide by 4 and divide by 4. So I can get that negative 2 is equal to my a. So now that I have that piece of information, then I can plug it in. So now I'm going to rewrite what I have. So rewrite using a is equal to negative 2. So I know from my general equation that f of x was equal to my a, and I had my x minus my 1 and my x minus my 4. So f of x is equal to negative 2, x minus 1, and x minus 4. So what this tells me to do is to actually FOIL out that inside. So I have x squared minus 4x minus x plus 4. If I can combine like terms, then I have a negative 5x plus 4 inside those parentheses. So when I rewrite it, I have f of x is equal to a negative 2 that's being multiplied inside those parentheses. So when I distribute, I'll have a negative 2x squared plus 10x minus my 8, all equal to my f of x. And that is how I get my general form. Okay. So I hope this problem makes sense. Okay. All right. So we have more problems, and that's great because that means it's more content that you guys are going to be exposed to and more things that you guys are going to be learning and mastering. So here we go. It says rewrite the following in vertex form. Remember, you should all have this memorized what vertex form looks like. I know if I'm thinking about vertex form, then f of x is equal to a, x minus h squared plus k. And I'm going to go ahead and draw my line, because I actually messed up a while ago. This is actually my second take, because I confused both of them. So I'm going to work just over here for part A. I'm going to really try to focus here. So I know a couple of things. I know my A value, my B value, and my C value. So I'm going to go ahead and write it. So I have that A is equal to 4, B is equal to a negative 16, and C is equal to 17. So I'm like, perfect. I know what my A value is. I'm already partially way there. The other thing I need to understand is my H and my K. So how do I find my vertex? Well, I'm going to find my vertex by plugging in the formula. So x coordinate of the vertex is negative b over 2a. So negative b over 2 times my a value. So what I'm plugging in for my b is negative 16. What I'm plugging in for my a is a positive 4. So I'm going to have a positive 16 divided by 8. So positive 16 divided by 8 is going to give me a positive 2. Okay. So far for my vertex, I'm going to have a positive 2. That is my h value. Remember, to find my k value, I plug in that h value and plug it into my original. So here, x is equal to 2. Find y, which is really k. So in my original equation, I have that y is equal to 4x squared minus 16x plus 17. So 4x squared minus 16x plus 17. So that x value I'm plugging in is 2. Now I'm going to plug this into my calculator. So let's think about this. 2 squared is 4. 4 times 4. And I have minus 32 plus 17. So when all of that comes out, I'm actually going to get a, what is that? A positive 1. Okay, so I have a positive 1. So I have my k value as a positive 1. So I'm like, perfect. Now I know exactly how I'm going to be rewriting this. So I really have that f of x is equal to that a value that I have. So remember, the a value was already given to me. That was 4. And I have my x minus that h value, which is 2, plus my k value, which is 1. And just that you remember, this was my h, and that was my k value. And so that is going to be my final answer. 4x minus 2, oops, I forgot one thing, squared, there we go. 4x minus 2 squared plus 1. Okay. Now, let's try to do that again for part B. So for part B, I'm looking at this, and it looks like the first thing I want to do is identify my A's and my B's. So I know that A is equal to positive 2, and my B is negative 6, and my C is equal to a positive 7. So now I want to be thinking about the x coordinate of the vertex. That general form is negative b over 2a. So I have negative parentheses, 2 over my parentheses. What I'm plugging in at the top is my b value, that's negative 6. My a value at the bottom is a positive 2. So I have a positive 6 on top and a positive 4 on the bottom, so that gives me a 3/2. So for my vertex, I have 3/2 for my h value. Now I have to figure out what that k value is going to be. Remember, that's when I plug in that x is equal to 3/2 and plug it in. So x is equal to 3/2. Now I'm going to plug it into my original equation, which was that 2x squared minus 6x plus 7. So 2 parentheses squared minus 6 times parentheses plus 7. So what I'm plugging in is my 3/2. And what I get out, I actually get this out to be a positive 5/2. So my k value is equal to a positive 5/2. Now I'm like, perfect. Now I know exactly how I'm going to write this equation. So I have f of x is equal to the a value. Remember, a was given to me. That was 2. And I have here as x minus 3/2 squared plus my 5/2. And that is how I'm going to get that final answer there. Okay. I hope you guys are enjoying the lecture so far. We're about halfway through. So, now for this part, we have domain and range of a quadratic function. So remember, the domain is all of the x values and the range are all of my y values, in case you have forgotten. So domain, I am thinking about x values. My range, I'm thinking about my y values. And we write this in interval notation. So that's either the parentheses or the brackets or a combination of the brackets and the parentheses. And we always write it from the minimum value to the maximum value, in case you need a little refresher. Okay, so it says find the domain and range of this function. So, okay, so if I'm thinking about the domain, for the most part, the domain is always going to be from negative infinity to positive infinity. So the domain is all the real numbers, unless it's something weird. So here, when it says find the domain, well, it's all the real numbers, and there's nothing weird about this. So I'm going to say that it goes from negative infinity to positive infinity. So my domain, since it's all the real numbers, goes from negative infinity to a positive infinity. And you're like, but wait, how can you be so sure? Well, if I think about this, let's think about our vertex here. Or let's think about, our vertex. So we have our h value and we have our k value. So my vertex is going to be 4/7 and 8/11. Now I'm just going to draw a general graph. It's not going to be perfect and it's not going to be pretty, but it's just going to give me kind of at least a ballpark of what this looks like. So if I have the vertex 4, 7, 8, 11, then the x and y are both positive, so I'm in the first quadrant. So I don't know, maybe I'm like somewhere over here. That 2 is my a value. It's positive, so I know that I have a happy parabola. So like I said, it's not going to be pretty, it's a rough sketch, but now I kind of have that outline. So definitely looks like these x values, it's growing this way and it's growing that way, which is left to right. So the domain is going to be from negative infinity to positive infinity. Now, if I look at my range value, that's going to be something I have to pay attention to. So my range here is always going to be, remember, the y values, and it's always going to be bigger than the k value. So let's think about this. So this vertex right here, I have h, comma k, which is actually the 4/7 and the 8/11. So my h and my k value. So that k value is going to be the minimum y value. So I know when I'm going to be rewriting my range, that my range is going to be from minimum to maximum. So that minimum y value is going to be 8/11 all the way up to, bless me, all the way up to positive infinity. Okay? All right. Well, I hope that's helping. Let's look at the second example. So for this second example, I'm going to be looking at it. And well, here I can definitely see that my a value is negative. So a is equal to -5. So that tells me that I'm going to have a sad parabola. Okay? So because it's in this general form, then I know that my domain is going to be from negative infinity to positive infinity. Okay? Now the range is the one that you really want to be careful of. The range is always going to be dependent on what your actual vertex is. So maybe I'll put that over here. To find range, which are your y values, find vertex. So I need to find my vertex before I can actually think about my range, which is fine. So I know that I have the x coordinate of the vertex by that negative b over 2a formula. So negative b over 2 times my a. Well, I know for a fact that my a was negative 5 and my b was positive 9. So I'm going to plug in 9. I'm going to plug in a negative 5. So that tells me I have negative 9 over negative 10. So I have a positive 9/10. So okay, so my vertex, so far I have 9/10 as my h value. Remember, to find the k value, I just plug it into my equation. So x is equal to 9/10. Now I'm going to plug it into negative 5x squared plus 9x minus 1. So I'm plugging in my 9/10. And when I plug that all in, I'm going to get my k value. That k value is actually 61 over 20. So that is my k value. So 61 over 20 is my k value. So 9/10, comma 61 over 20. So now I can tell you that my range, it actually has a maximum point. And I also have my minimum point, since it's going down, 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 down. It keeps going down, keeps going down, keeps going down. So I'm going to say that my range goes from negative infinity, and that maximum point for the y value is 61 over 20. So that is going to be my domain. So like I said, the domain is a little bit more work, but it's definitely going to be doable. Okay. Now, next problem. So here I have the output of a quadratic function at the vertex is the minimum or maximum value of the function, depending on the orientation of the parabola. We can see the maximum and minimum values in the graphs below. So I want to be careful, there's a small typo. So this is definitely the minimum value, but in the second graph, because it's a negative parabola, we actually have the maximum value, okay? So the value actually occurs at the y coordinate. So value is at y coordinate. So this is my y coordinate. So whenever we're thinking about value, always think about the y coordinate, or better yet, the k value, okay? All right, so I'm going to be thinking about this as I approach these problems down below. So, okay, it says, a sales team estimates that the number of new phones that they will sell is a function of the price that they set. They estimate that if they set the price at X dollars, they will sell the function F 1,720 minus 5X phones. Find the price X, which will maximize the company's revenue. So it says find the price X, which will maximize the company's revenue. So when it specifically says maximize, well, hopefully something should be coming into your mind. Whenever I see maximize or minimize, that's my buzzword to find the vertex. Okay. So when I have a vertex, I'm definitely going to be thinking about a parabola. So that means my equation is definitely going to be a degree 2 type of equation. So I'm going to be looking at this and I'm like, okay, well, it specifically says the company's revenue. So maybe I should get that formula first. So if I'm going to have revenue, and for this particular example, my revenue is going to be the price of the phone, and it's going to get multiplied by the number of phones sold. Okay, and let's just reread what we have. It says that the estimate that if they set the price at X dollars, they will sell this many phones. So in this particular case, X is equal to our dollars. And here we have the number of phones as my Y value. So, okay, that's important to know. So then we have our function. We have that f of x is equal to 1720 minus 5x. And what that tells us, it's going to be the price of the phones. So price of phones. Okay. They estimate that they set the price at X dollars, they will sell that many phones. So we are going to have now that my revenue is going to equal to the price of the phones, which I have, and also the number of phones sold. So I have my 1720 minus 5x, and the number of phones sold, I don't know what that is. So that is going to be my x. Okay. So now I'm going to have this revenue, let's call it R of x, is equal to 1720x minus 5x squared. Better yet, let's say it's going to be a negative 5x squared plus 1720. Okay, so now that I have my general equation, now I can do some stuff with this. So now I can tell you what the maximum or the minimum point by telling you what the vertex is going to be. So if I look at the vertex, I know I need to be figuring out that negative b over 2a, since it's the x coordinate of the vertex. So I have negative b over 2 times my a. So I have my a value as negative 5, and my b value as 0, and my c value as 1720. Actually, scratch that. I forgot something here, didn't I? This is 1720x, so I should have had an x here. So my bad. I should really say that my b is equal to 1720. There we go. That makes a lot more sense. So my b value is my 1720. And the a value that I'm plugging in is a negative 5. So when I plug that into my calculator, I'm going to get 172. So that's going to be the x coordinate of my vertex. And that's exactly what I need. So I know that 172 is when the company will maximize the revenue. Okay. So, and that is the price that they're selling it for. So, perfect. All right. Now, let's go on to the next problem. So here we are on page 7. And here I'm going to take a little break because I've been doing this for an hour. And so it's going to be part 2 later on. Okay, so I finished 5.1, part 1. Part 2 to be continued on page 7.